Data sufficiency. Now these are a new set of problems being introduced in the exams a lot these days. Before moving forward with understanding how to solve the problems on data sufficiency, let's understand what is the difference between data sufficiency problems and the normal problem solving approach. Normal problem solving approach is simple. You have a simple formula and that you have to apply and you are all set to go. A simple maths that is required. But when it comes to data sufficiency, it's much beyond maths, it's logic. You have to understand the reasoning for it, and a logical derivation of concept would help you sail and understand whether it is a solvable problem on your end and not. It comes a lot with practice. So usually when you have a data sufficiency problem, there are either 2 or 3 statements. We'll do some examples with 2 and others with 3 to help you understand, where it says statement 1 alone is sufficient, 2 alone is sufficient, both are required, both can answer the question independently, but they are not mutually required, and we cannot answer the question even by either of the statements. So those are the kind of options that you usually have with a data sufficiency problem. So we are beginning with a very simple example to help you understand this picture very clearly. So there are 2 boxes of different color. Now the given question is the box B red in color? So let's say this is box A and this is B. My question is the box B red in color? And the given statement is 2 boxes are of different color. That means if I want my box B to be red in color, my box A should be blue in color. As simple as that. So my box A is red in color. That is wrong, because if that is true, box B cannot be red, because both the boxes have to be of different color, and box A is blue in color. That is correct. That means statement B alone is sufficient to answer this question. I do not need both the statements, and it's also not a non-solvable problem. It can be solved easily. Okay. Now the next question here is, what is the total cost of 5 pen and 5 pencils? Now this is a problem of mathematics, but you need not to solve the whole of the problem here. I have the question, 3 pens and 2 pencils cost rupees 30. So 3 pens plus 2 pencils cost 30. Okay. 2 pens plus 3 pencils cost rupees 20. Okay. Now I need to find out the cost of 5 pens and 5 pencils. So if I have both the equations, I can simply add up these equations and say, okay, the cost of 5 pens plus 5 pencils would be how much? It would be 50. Okay. Or I can say cost of 1 pen plus 1 pencil would be 10 rupees. Now here what I have done is, I have 2 equations and each of the equation has 2 variables. So 2 equations with 2 variables can be solved only when you have 2 equations, and therefore both the statements would be required to solve this question. Very, very simple. So this is a problem from mathematics that we have done. The next problem that we would be covering would be from a analytical reasoning and then from a coding decoding problem. So we would be touching various kinds of problem to help you understand better how to move forward with data sufficiency questions. So I repeat again, this is a question on linear variables, 2 equations and 2 variables. So 2 variables, if they are there have to be 2 equations in order to solve that problem, and therefore both the statements are required to solve this problem. Now here first is the question says there are 6 people and who is the heaviest. Okay. The first statement say P is heavier than 2 of them. I don't know who to. S is heavier than R. S is heavier than R and Q. So S is heavier than R and Q. There could be people who could be between them, but S is definitely heavier than them. R is lighter than Q and N. So R is lighter than Q and N. That means Q cannot be on this side. Q has to be heavier than R, and then also N has to be heavier than R. But N is heavier than P. N is also heavier than P. So I know N is heavier than P. Okay, then Q and R remain. So I can say Q and R are here. And then I say that N is heavier than P but lighter than S and M. Okay, it is lighter than S and M and S is lighter than M. So S is lighter than M and N is lighter than S and M. So I can bring S and M here. So based on all three statements, I can say this would be the series that would be there. Now it says who is heaviest. So I can say M is heaviest, and that could be derived only once I take into account all the three statements. Unless and until I do not take into account all the three statements, I cannot come up to this equation. And this equation, unless and until I come up to, I cannot say who is the heaviest. So all three statements are required in order to solve this problem. So when you have problems like these, you have to understand, okay, if I was working with just first statement and I was able to solve this problem, then I would say B and C are not required. But in this case, I used the first statement, I could not come up to the answer. I used the second statement, I could not come up to the answer. And therefore, I used the third statement as well. And then I was finally able to land up with the answer. If the last statement said S is equal to M, that means both of them are equal, then who is heaviest? Then my answer would be S and M. But still then I would be able to come to a conclusion only based on the third statement that is there. So all the three statements are required in this case. Let's take another example where I am talking about coding decoding problem. So the first statement says cake chocolate sweet is coded as hi, nai, mai. Now cake and cake is here. And sweet is here. Okay, so two of the words sweet and cake are here, and two of the common words that are there are me and ni. So me and ni make sweet cake. That's clear from the first statement alone. I need not to go to the second statement, but let me check second statement. It can be a scenario where both are true. So here I have the word cake, and here I do not have the word cake, but here I have water and water. So what I can derive is the acronym for water, the coding for water, but not the coding for cake and sweet. So this statement is not sufficient alone. Since it's not sufficient alone, both of them together also cannot be sufficient, and the only scenario that can happen is one alone is sufficient. This year in UPSC prelims, we have witnessed numerous questions on data sufficiency, and therefore it has become a very important part of logic for your upcoming other exams as well. So practice well on data sufficiency problems. We would be coming up with many more interesting problems in data sufficiency. The only thing that you need to understand is logic, and try to hide each of the sentence and see if you are able to solve it with only first statement, if you are able to solve it with only second statement. Do you require both the statements, or even by using both the statements you are not able to come up to an answer? So those are the various conditions that could come up. So it's a kind of logic and conditional problem that you have to understand. We have also covered a series of logic lectures which are not directly asked, but to understand this in more detail, to develop an applicative mindset, those can be useful for your understanding. And as we said, practice a lot of questions. GMAT CAT have a lot of questions on data sufficiency, so don't miss this section, a very scoring section, and rather don't be afraid about it. It's a really scoring and a challenging section. We would be covering many more interesting lectures on data sufficiency. Stay tuned. Have a wonderful day ahead.